So hello everyone and welcome to the February edition of the OpenLineage TSC meeting. And just as a reminder that you've probably seen when you joined the meeting, these meetings are being recorded and archived on our wiki as well as other media pages. So we always like to start the meeting by a quick roll call. I think a lot of familiar faces here today, but still be good to say hello. So starting from my top left corner on my screen, Tomasz, do you want to say hello?
Hey, I'm Tomasz. I'm a data engineer at Getting Data, OpenLineage committer, and today I'm just here to listen to Guy's presentation.
Thank you so much. Good to see you. Pavel?
Hello, I'm Pavel. I'm software engineer at Getting Data, contributor of OpenLineage, and I'm here to present some of my short thoughts about partitioning and subsetting a dataset.
Thank you for preparing and being here, Pavel. Next up, Maciek.
Hey, I'm Maciej. I'm a software engineer at Datadog, and I will talk about tags today.
For those who were not sure, this was tags and not tax. That's what I heard. Maybe it's because it's tax filing season in the US. Next up, Michael Robinson.
Hi, everybody. Michael Robinson, OpenLineage contributor and community person, and I'm here looking forward to some great presentations. It's good to see everybody.
Good to have you here, Michael. And as always, please provide your ratings on how I'm facilitating this afterwards. Next up, Leo.
Yeah, Leo Godin from New Relic. I did my taxes this weekend, so I'm very interested in learning about tags and realizing that New Relic and Datadog worked on tags together.
That's a happy coincidence. Thank you for being here. All right, up next, I'm going to tag Daniel.
Hi, everyone. Daniel Rolls, CEO and founder of BearingNode, and consultant to organizations using OpenLineage and vendors who use OpenLineage. So, yeah, that's me. I'm here to listen today.
Good to have you here again. Thanks, Daniel. Mr. Ladem, care to say hello?
Hello, I'm Julian. I also work at Datadog. I'm the lead for the OpenLineage project, and I'm looking forward to hear the presentations today.
Thank you, Julian. Good morning. And Luke, last but not least.
Hey everyone. Yeah, I'm Luke, solutions architect at Atlan. So from the consumer side of things, super interested in how OpenLineage generates events and everything. And I work a lot in the field helping customers implement it for Spark. So I'm interested in learning more in the community and getting more involved and maybe someday contributing. I'm not a software engineer myself, but definitely interested in learning more. So happy to be here.
Great to have you here, Luke. As always, all are welcome. All right, I'll go last. My name is Harel. I am an engineer manager at Datadog, and I work on OpenLineage as well. All right, on to agenda items. So quick reminder of our communication channels. I think actually we have a Blue Sky account now, thanks to Michael. We just need to add it to this list. So on the agenda today, quick announcement on an OpenLineage meetup in Warsaw. Then we'll go through the recent release, and we'll have two presentations today. One from Pavel about dataset partitioning and subsets. I think we're not going to talk about async circuit breaker today, but maybe next time. And then we're going to talk about tags. Tags. So Maciej is going to present some ideas for the Java client, and then we'll open the floor for open discussion. So Michael, do you want to start with this quick announcement?
Yeah, so there's an exciting meetup coming up April 3rd. It's a hybrid event. at Google in Warsaw. Thanks to Jens Pfau for organizing this on the Google side. We had a very well-attended event a while back, also in Warsaw at Google. So this promises to be excellent. If you can make it, please RSVP by March 31st. There are more details on the OpenLineage blog, including a link to RSVP, and there are some requirements because of the Google site entrance kind of rigmarole. So please read the meetup page carefully, and we look forward to seeing a lot of folks there.
Nice. Looking forward to joining remotely and seeing pictures. Thanks for organizing to Jens and the GCP team. All right, next up, I'm going to quickly go over this recent release on the project. So a few things that were shipped thanks to some of our most frequent committers on the project. So Pavel shipped on Java added support for providing configuration for SSL context as part of the HTTP transport in the Java client. Then adding support for filtering nodes and when scanning through Spark jobs, so you can see the configuration documentation for details there. We have a first-time committer, our contributor, Ari. I'm sorry, it's Ari Trabandio, who added circuit breakers on the queue back in thread pool. This is actually causing some resource contention issues for certain Spark jobs. So thank you for your contribution. And another first-time contribution from Whitley Keith, adding support for the Trino adapter as part of the DBT. Just as a reminder, we also have native support baked into Trino for OpenLineage. And then Santham, returning committer, increased coverage for Spark DML commands. So you can check out the PR to see which commands have support there. Also, things that have changed. So Pavel added actually different handling for how we raise exceptions when an unsupported catalog is being used in Spark. I've experienced that myself. It gets very noisy. Thank you for doing that. We also have Damien from Booking adding some initial refactor to a subsequent larger refactor on directly exposing the logical plan and Spark plan objects inside the OL context. Also a couple of fixes. So Pavel improved column lineage by actually including the input datasets within the complete event, so you can capture full column lineage and all the data would be there at the complete event. And Massey, now the parent run facet is correctly attached when using the structure logs reporting option for the DBT integration. Thank you for all committers and contributors, both old and new. That was a Game of Thrones reference. Sorry. Pavel, I'm going to hand it off to you. Do you want to share your screen or do you want me to keep sharing?
I think we can go through the slides, and if you could just from time to time go to the next slide, would be great. So for the last few months, I was working on the partitioning proposal. It means like I started working on it in October, then revisited in December, then revisited in January. And, you know, anytime I revisit it, I think we are pretty close to having it ready and merging it. And then someone else bumps and says, hey, what about this? What about that? And, you know, this feedback is really helpful. Harald, can you go to the next slide? And it brings the proposal to something way better. So at the beginning, I would like to thank Dolphinus and Maciej for staying on the dock with me and commenting its content, and it's very valuable. And I've added you guys as the co-authors of this. And yeah, thank you for not hating me so far for those changes. Yeah, why do we do it? Why do we want partitioning metadata? Actually, we would like to answer 3 questions. Like, we would like to know if and how is the dataset partitioned. And it's like similar to schema facet we have. It's perhaps some columns are used for partitioning purpose. And actually, there are two other questions we'd like to have answers for. It's like, what partitions have been picked by a job if have been read? Yeah, what partitions have been affected by a job if the job writes to certain datasets? And it seems that the question 2 and 3 are sub-problems of a more generic problem of how to describe a subset of a dataset that is involved in the processing. And partitioning is like, one of the few cases we would like to support. And so throughout this month, we have started from the partitioning facet, and then I included the subset definition facet within this proposal because I think it makes more sense to have it in one go, and it doesn't make sense to prepare partitioning proposal if you don't know how to describe definition of a subset of a dataset. Yeah, so the proposal is 3392. It's linked here if you want to read it. Please go ahead. And if we can go, the first thing is, let's describe how the dataset is partitioned. And actually, these are two examples of the ready facets. It's a partitions facet, and it contains an array of dimensions. And each dimension can be a transformation of one or many fields. Yeah, so the easy and common scenario is that it's just an identity on a single field. However, this can be something more complex, like a function called on this field. And so we do have like transform field, which is a string. Identity means just the column the field is taken, but it can be more complex than that. And it's a string, so you can put anything you like. We do have also the description field for the partitions, which in terms of SQL, it can be the partitioned by SQL clause. I think it's not possible for the consumers to automatically read it, but it's really useful for humans to know how a dataset is partitioned. And I think that we also got some help from other people from Datadog in properly naming the fields. This is good enough to describe what schema fields are used for partitioning and how are they used. And then we can move on to trying to answer the how to define a subset of a dataset. And it's a bit more tricky, I would say. Okay, perhaps does anyone have a question related to this example facets? If not, you can always ask them later, and we can move to the next slide, which starts how can we define logical subset of logical subset definition. Sorry, so it's like we can have a binary condition definition, which is like something and something, something or something, which allows merging different conditions. We can introduce the compare condition. And based on that, we can have a facet. This will be input or output facets because it's not describing a dataset. It describes how a dataset is used within the context of a certain run. And based on this, we can describe the SQL query we have on the left, like to where filtering conditions, and we can convert them to facets and have more of them. Okay, perhaps it's working, but actually it doesn't cover all the cases of possible filtering and subsetting a data set. And the other possible scenario is partitioning. Harel, if you can go to the next one, is a job can read several partitions, can write to several partitions. So another way to define a subset of a dataset would be just list the partitions involved. And this can be done by containing a facet with the dimensions values, yeah? And this is another way we can define a subset. There's also a third way we can do that on the next slide. And it's physical location based. Yeah. So if we have a Spark job that reads like 10 files, we can list the files. And yeah, assuming a dataset has like thousands of files, we are reading just 10 of them, then having the list of 10 files is a valid subset definition. And it's actually really useful. And yeah, because, for example, for Spark integration, we can have an access to physical plans. So we're always able to get the list of physical locations that are processed. Even if a user defines a dataset by a wildcard, we can resolve it because Spark resolves it, yeah? And yeah, you may wonder what's the correlation between the logical and physical plan. And actually, I believe there's none. Because, for example, for Spark, you can read a dataset through the physical locations, and then you can apply some logical filtering on it. And so you can combine those two approaches. And yeah, actually, it's difficult then how to describe, how to create a proper definition of a subset. Yeah. And the fourth subset definition that yeah, that we created on the next slide is actually we don't know anything about the subset. Yeah. And actually, it's fair to say that oftentimes OpenLineage won't be able to provide a concrete subset definition that can be read on the consumer side by an algorithm. And yeah, I asked AI to provide a complex where condition, and this is what it created. And perhaps you think that you can provide a facet that describes how to obtain a subset of a dataset for such SQL syntax, but then, yeah, someone else can bring more complex words. Yeah. So there will be examples where the best we can provide is a description of the subset, which can be like substring of the SQL query, yeah? Like in this case. So we do have at least four ways to describe a subset. First is like logical conditions, combinations of binary operators and column conditions. Second one is partition based. We provide the list of partitions. The third one is yeah, physical locations. And the fourth is yeah, let's try to tell a story about how that is partitioned. Yeah. And it's yeah, it's difficult to provide a subset definition in four ways because actually, for example, within Spark, you can have a compilation of any of those two approaches. So something that I included in the proposal on the next slide is best effort hierarchy proposed. So because I think this information have different values. So if you are able to identify a subset by the partitions read or written, that's all you need. I think that's the most valuable information we can get, assuming we don't want to do row-level lineage. So if if a producer, if integration is able to detect the partitions, then forget about logical filtering, forget about descriptions, just provide the partitions and it will be good enough for our purpose. Yeah. So perhaps we can allow users to provide a configurable maximum amount of partitions detected. So if you detected that your job reads 10,000 of partitions, don't include it in a facet. It's not usable anymore. Then I would say that physical locations are the second item in the hierarchy. So if you're able to detect the files or directories touched, please define a subset based on this. Don't use wildcards because it doesn't make sense in this case. And it's a bit worse than partitioning, but it's still, it's still some pretty valuable information on the part of the dataset that was manipulated. If you cannot do any of those two, well, then it's good, and you can detect the logical conditions applied. Then please provide a facet based on this. And if none of the three top approaches are working, use the description-based subset definition. And because still, if on the consumer side you present it to the user will be able to read and have some understanding of what part of the dataset was touched. And yeah, that's all.
I like the limiting of the, let's say, parsing and providing just the description, because I think the previous version, like, assumed we can always describe this, and it could go pretty deep into those weird SQL conditions. Like you showed, it maybe wasn't the most extensive SQL example we could show, but it's already showing that partition condition will be hard. So yeah, that's really good direction, I think.
And so in most cases, if 1 and 2 fall through and you can't do it, I'm thinking like Snowflake, right? You're not going to list micro partitions in here, probably, even if you could. Then you get down to the logical, and then in some real complex use cases, you're just going to give the description. But in most cases, if you fall through the 2, I imagine 3 will cover a huge percentage of what's left, right?
Yeah, like probably the largest part will be covered just by the first one, right? I mean, like the description is just to handle those edge cases. Like, so we can just say, okay, that's too complex for us. So like that's probably will not be that much used anyway, right? I mean, that's the assumption.
I'm just thinking of like, yeah, I get it probably doesn't matter, but I'm thinking of like Snowflake, BigQuery. Well, BigQuery has partitions, so I guess maybe there's only a few exceptions where where the concept of a partition doesn't really exist, or at least an identifiable one. But okay. And then what about I'm just looking at the last 2. You have like, so you could have a where clause in a SQL statement. You could also have like limit and offset. Would that fit into those at all?
So yeah, I think it would need some extension, because if you go into the proposals, I propose some data structures that's with a few examples, you can add more of them. So yeah, I think yeah, it's called base subset condition, and so far there's no such condition that allows you to provide ordering and limits, but it can be added in future.
The problem with ordering and limit is that it's contextual, right? So 2 executions of the same query can have different results.
Yeah, and also it's like the ordering and limiting, it's kind of a different than because when you use the partitions, then you are kind of limited by the input you have, right?
Mm-hmm.
Like it describes the inputs, kind of. And in case of ordering or limit, it just, that's kind of just display feature, like data display feature. I'd just say.
Yeah. I do like how this is generalized. So, an S3 bucket could, in theory, be a partition of a data set. Or,
I mean, very often is, but like
yeah,
hundreds of different data sets with each having time-based partitioning, right? Date-based.
yeah, even
That's-
CSVs somewhere could be in a folder, and yeah.
So I had a quick question, like in the case of S3. So one thing I've noticed in my experience is that if the S3, if you are reading an S3 path or a S3 data set that is partitioned, like you use a wildcard or something like that, then the actual input facet will have a separate input for each partition. Will this new proposal switch that to having the data set that's being read be one input in the inputs array? And then, for example, let's say identified by partitions is defined, or even let's say identified by physical locations is defined. So that list of partitions is defined inside one input instead of multiple inputs defining the partition. Is that how it's expected to work going forward?
Yeah, actually, I know there's an issue for this. I think you recalled it. I don't remember what's the output of the discussion. So my preference is always to have like a single data set with a single directory. And actually, within this proposal, I wanted to add some configurable way to extract partitions from S3 paths or location paths, because you may have the directory location with some equals characters and which are partitions, but Spark is actually unaware of this. So perhaps you can configure the Spark connector to be aware of it and include partition facet in if such location path is detected. Yeah, but actually I don't know if it should affect the way the data sets are recognized now. I think it's a different issue actually.
Yeah, the problem usually is that you might write to some path, right? But it's some path for you, or read from some other path in S3 bucket. And the fact that it's actually a partition is defined by something external to the, I don't know, Spark that reads or writes it, right? It's not like there is data catalog that has this information. So sometimes it's kind of contextual information, right? And I don't know, we could guess that, okay, we have a time in a path, like year, month, day or something, but that wouldn't be very accurate, I think, in many cases.
Yeah, and also
I think we'll create an issue for this later, and I will link you because I think you can have like great examples of weird partitioning.
Yeah, that'd be great. Thank you.
Okay, any last questions, feedback? All right, so
Sorry, just one quick question. So whenever you pick which type of partitioning you represent, you will have a clear way to know which one you use, right? Like it's part of the facet to know, hey, and this is methodology we use to represent this.
There is a question.
So because depending on how you were able to identify the partition, you use one of the 3 or 4, right, cases.
Yeah.
And then in the partition itself, there's like a type that defines which one it is.
So Harold, if you can scroll one slide down. No, this is something. This is one slide below. The next one. This is like the if you're able to detect partitions affected by a job, then such a facet should be generated. So it lists the partitions, and each partition is identified by the value of the dimensions within.
Okay, yeah, so that's the subset. It's that top level fields that determines which type we're using.
I think so. Julian, is the question is on how do you know the type of
Yeah, so you have
partition?
subset partition or subset locations. Okay, yeah, type locations. Yeah.
Oh, yeah, there's a type field. Yeah.
That
I think it's missing in one example.
in some, yeah.
Yeah,
As
so
a type-
here we do have like conditions which are identified by type, and here, okay, I think here it's missing. But if you scroll to the next slide, I think,
Okay,
yeah, there's a type location, and yeah, here there's type description, and on that slide there should be type partition.
Yes,
okay.
here it's missing it.
Yeah.
So you have the type that tells you, okay, that it's missing there. So it's a type field.
Yeah,
that-
actually, that's something that's much identified earlier. So that's relying on ID is not the best solution, and that's why we added types.
Okay, thank you.
Okay. So thank you, Pavel, for presenting and preparing this. So any other feedback, please go to the PR for the proposal or on Slack. And with that, I think we'll move on to tags.
So yeah, maybe you can also control the
Sure.
presentation. So yeah, next slide. So yeah, first thanks for Leo for driving the discussion about tags and implementing it in Python, creating a specification. And it's no wonder that observability companies care about tags, since it's a very powerful mechanism. And they are used for literally hundreds, thousands different use cases. Usually for grouping stuff that makes sense to be grouped together, like attributing ownership, some security-based stuff. And like in this case that I showed here, it's just an Airflow UI. And Airflow UI allows you to group the your tags by some arbitrary labels. And then you can filter it and show only the relevant ones, the users. So tags are kind of arbitrary metadata, and they are usually for in-string format. So next slide, please. Yeah, but we already have arbitrary metadata mechanism in OpenLineage, right? We have some facets that can show you the end variables that user configure OpenLineage to send, Java properties, and you can argue that all facets are a mechanism to send the arbitrary metadata, right? So there are a couple differences. I think like environment variables, Java properties are more by like created for the machine consumption production. So like you can configure some connections, secrets, not the best security minded use case, but you can do stuff like that with environment variables, while tagging is usually not the good way to share your secrets. And they're kind of more unstructured information compared to OpenLineage facets that aim to be standardized way to send some information, right? Like we already have an ownership job facet, but you can also send this information via tag if your specific use case already does that, and you don't want to force everything to be compliant with OpenLineage specification, maybe. And yeah, if something is truly a standard, we will still not rely on sending everything via tags. We'll create new facet if we want to standardize this. But it's the way that's already being used, right, in the wider world. So we should take care of that. Next slide, please. So tags aren't that easy as it may seem. So the format, first thing is, it's not very obvious. And I have a screenshot from some Datadog documentation here. And you can see that it's a cluster of various words, numbers that might not be very user-friendly. And what you can see here is like container ID, something, fine. But then you have GOG, GKE node. And this is like what I would call a label rather than tag, because it's like a single word. It's not key value information, right? And this kind of tags also do exist. So our mechanism should take care of both. And yeah, we have to deal with kind of stuff like that. Also, I said like tags are mostly used for like user-facing stuff, but here those are some Kubernetes tags, or they call them labels. And in Kubernetes, it's used for very much of a machine use cases, such as those own host maintenance, migrate, or pod phase, I don't know, probably enable OS login. So your mileage may vary, but it's also something that end user should see if they look at their pod, for example. Next slide, please. So this is some Kubernetes kind of stuff. We don't really care about this in OpenLineage, but we should care about all those formats and how we can attach tags to OpenLineage events. So our format is more complex. It's not only label or key value, but it's key, value, and source. And we also capture source of attack compared to just capturing the its key and value. And why is that? Because the tags can come from various sources. Mostly, we want to distinguish between case where user is passing this directly to OpenLineage client via some configuration, for example, via SparkConf. Or are we just capturing some integration native tagging mechanism, which is like this Airflow one that I showed at the start. And like the OpenLineage consumer could know what's the source and that they want to do something specific for those values. And so what's the structure? So we don't have a single tags facet. Due to JSON schema limitation, we had to do like 3 separate tags facets. And so we can tag runs, we can tag jobs, and we can tag datasets. Those are pretty much the same with one difference. The tags dataset facet has also a fields field that allows you to specify what particular field the tag is describing. So basically tagging a particular column, which makes sense in like personal identifying information situation. You have a tag in some column. This is sensitive information, you don't want to share it, right? And how can, so Java support is coming in the PR number I've seen, and it allows you to specify the tags using the config as shown on the right. This is like test cases that I have for this feature. Basically, you can specify it as any OpenLineage configuration option. So this example is for YAML configuration, and you specify it as a list, and you can specify the key value source values by splitting them by column. And yeah, it can be anything really, but there are some also malformed cases that we have to take care about. And yeah, maybe next slide, please. So for Spark specifically, there is no native tagging mechanism. You can't like tag stuff in Spark in some UI. Spark doesn't have a great UI, let's say, natively. So what we are doing is we allow you to configure the tags via SparkConf. And here you can see an example. You can separate those different tags via semicolon. So there will be key value, KVS. If you do some mistake, like add one additional tag, it will get skipped. This does not allow you to set up dataset tags because we don't know the datasets before the job gets run. So in case of dataset tagging, I think it needs to be done on the other layer if you want to do that. Next slide, please. So one use case I've noticed for dataset tagging is that Iceberg has some specific branch tagging, and you can use those to retain some, let's say, GDPR requirements, some historical snapshots. And if you notice that, okay, you're reading from that kind of branch or writing to them, this kind of data, you can actually express this information via dataset tagging. This is an example. We don't support something like that yet, but I feel like it would be nice to have support for this. Next slide, please. So one thing we are not yet capturing, and this is actually Python, not Java, is DBT tagging. DBT has tags for a lot of different components, models, snapshot seed queries. Yeah, and they use pretty similar mechanism, but as you can see, it's mostly like labeling rather than KV. Next
There's
slide,
a
please.
second form of arbitrary metadata for DBT, which is what they call their meta config. And it's essentially a dictionary you could also have for models tests. And I think we should include that in the tags as well.
Yeah, I agree. We should, if integrations have that kind of stuff, that's, I think, the primary use case to capture those in our integrations. But yeah, information is often duplicated, and I guess it's not a bad way to duplicate it. Yeah,
it's usually not duplicated in the examples I've seen, but yeah, I'll start a discussion.
Mm-hmm. And next slide, please. And the last example is the one I started with. So Airflow has tag labeling, and this is something that we actually capture now, but we capture it as a part of like general Airflow run facet, and the format is kind of messed up there because we serialize the list of strings to a string, and then it's not very useful to the end user unless they parse it. So it's also a good candidate to be implemented very soon in this way. And yeah, thanks. That's the overview of current state, I think.
I have a quick question on the use cases of the tag integration. Is the scenario for tag propagation be also addressed with this? What I'm thinking is, the Spark job runs from, a source to target. The source table has tags, and we can go as sophisticated as like, okay, the transformation makes that particular source obsolete, so the target doesn't get the tags. Okay, it doesn't get obsolete. Oh, now the target has to get the tags. Is it also a part of this use case?
I think that's kind of integration specific, whether those kind of tags get transmitted, right? I think it theoretically is possible, but in practice, we don't know if like PII tag is something that we should transfer between datasets or columns, right? So in practice, I think we will send the tags from the dataset that has it, and then the consumer should like decide if this is something they care to propagate. That's my view, at least. Maybe somebody will give you a different answer here.
Got it.
Yeah, because this is kind of guesswork. If we really want to do this. And
Got it.
for Spark, actually, we have the great transformation type feature developed by Tomasz here that actually tells you that whether the transformation modifies the column, the source column in some way. And if you can actually get the format of the source column in a way, so that, yeah, for this personally identifying information, the tags with combination of transformation types, I think they can answer that.
Yeah. This particular tag propagation is one of the biggest industry challenges, at least in my prior experience, and we always had to there was a gap in understanding what happens in the transformation, but given the Spark DAGs are produced, there is probably an opportunity, maybe not in the first iteration, but we can continue exploring. It has a huge value that I can say from the business side of things.
Yeah, that's definitely not the first time we hear about this. Yes. So if you have ideas how we can make this better, yeah, let us know.
Yeah. So I have one more question. When you talk about tags, key value pair and the source, by source, I'm just trying to get that clock in my head. The source here is the source system that is reporting the tags out of the box. Like, can you clarify it? Because let's take
No.
Snowflake as an example.
So the difference is that, for example, for Spark, maybe let's talk about Airflow, because there it's kind of easier to describe, right? You have this DAG tags that come from Airflow itself that users can provide in their own DAGs, or you can modify the OpenLineage config to say, okay, tag my events with this tag on the run, right? Or in the job. So in one case, we would have tags with source integration because they come from the integration itself. And on the other side, we would have tags coming from the user or configuration. So that's the difference.
Got it. Just to follow up on that, what about additional metadata that are associated with the tags, like the person who applied it, or any additional, domain that applied it? Is that also part of the value?
If it's not a part of like string representation of a tag right now, we don't capture it. That's the current state.
Yeah, we don't support capturing it, let's say, because like the capturing it's really integration specific, right?
I feel like, yeah, but I think in many cases you have events, let's say event log, something that tells you who added the tag or not. But going back to the Airflow case, it's literally part of the source code, and you have no idea when it was added, by whom. You could maybe scan the source code and get GitHub ID of somebody who added this first time, but this is not something that like Airflow exposes, from what I believe.
Got it. Yeah, you're right. It's a source specific. I can think of other use cases where additional metadata does get captured at the time of declaring a tag. Yeah, I'll think about providing more use cases as we come across.
There is a simpler form of tag propagation, by the way, that we could consider. For instance, maybe job tags should propagate to the run. I'm not sure how useful that is, but maybe even potentially data sets or something like that. I'm not sure how useful or important, but like there are simpler cases of propagation we might want to consider.
I'm going to agree with you, Leon. I'm going to agree with Shantanu. I literally had a conversation with a client the other day who's trying to solve this problem with ownership. So we've got a static data and a data and movement problem, like both, right? So the data sets at rest, who owns those, right? So aligned it to Shantanu, to your point, aligning to the data governance problem. align the data set the data comes from. So we can tag the jobs and the data sets to that data governance metadata, then that would be hugely powerful.
Yeah, and that can certainly be done in the integrations themselves in many cases. But we could consider something in the client that automatically does that. I think we'd have to be real careful with it.
Yeah, I
Put a
heard
lot
the
of
usual
thought,
principle.
but
Sorry, I heard the usual principle of consumer cares, right? That's what I think I heard. Marche.
True.
Just the usual principle that we. Sorry, I've only been in the community for 6 months, but the usual principle of consumer cares, right? You need to consider how you consume the data. Is the principle I've seen. That's the principle here, right?
We have to consider, but we can't force anyone to use the data in a way that we. Yeah, I mean, we're trying to make the events as much easy to consume for users, but we can't force semantics on them, right?
Great.
That's I think what we're trying to do. And there are many use cases for OpenLineage, right? So assuming that everyone is trying like to draw a lineage graph, for example, might not be the best solution.
Could be a just to throw another idea use case to do a bit on Shantanu's point, where I think this particular client was going and the use case of seen straight away is alignment to reporting requirements. So if you can propagate the tags right down to the base data set that's attached, for instance, to a regulatory reporting requirement, that would be hugely powerful.
Yeah, that's where I was actually coming from
I
as
figured
well.
that's where you were going. Yeah, so I just wanted to second your motion.
Yeah. Oh, yeah, something to consider. We'll come back with more use cases, customer validations.
I think like when I think about it, it's like the question of, for me, is like whose authority is to do this track propagation? Is it like the receiver of the data and then the repository of events kind of using the lineage and linking and propagating versus the producers? I don't have an answer. It's just kind of what I'm thinking about here.
like what should the spec be handling and what should downstream consumers handle?
Exactly.
I mean, there is crazy race conditions out there where, who calls the shots, the job or the consumer?
Yeah, not only that, but imagine how would you change a tag or remove a tag? So let's say Spark creates a tag on a data set. Okay, now I use DBT and I have some tags, and those tags go on the data set. And so my OpenLineage consumer is going to be reading two versions of tags. The client is never going to know which are the right tags. It only knows which are the tags that were supplied right then. So, I think there's a lot of logic that necessarily has to be handled by the consumer. And that you just can't expect stateless integrations to ever be able to figure out. And removing a tag is a specific example.
Yeah, 100%. I mean, I hear you. Ideally, if the tag is coming from the same source, it shouldn't be different. Again, that's my hypothesis, irrespective of a Spark job or a DBT job or a Fivetran job, because the source data set have the same tag, that the job of the job, sorry, the purpose of the job is to propagate the tags. We can talk about it. I don't want to further digress this, but I will bring back the exact use cases and we can further discuss in the next iterations.
Yeah, that would be awesome, actually. And this is you're not like this is what this meeting is for, right? Discussing these things. So it was a great
Mhm.
discussion.
Exactly.
Okay, so we have 2 minutes left, which does not leave a lot of time for open discussion. So unless anyone would like to add anything on that last topic.
So thank you to the team that working on that. Really, the amount of questions and comments illustrate what a hot topic. Well done.
Fully agree.
One question, maybe Luke, you can chime in as well. I know we have only 30 seconds. We'll drop the question, and if you can point to some person where we can noodle this thought offline, that'll be great. Luke, do you want to quickly chime in on the recent issue that we have potentially
Yeah.
identified?
Yeah, so an issue that we've seen, and we've seen it before, but essentially sometimes event sizes can get really large. And due to consumer architectures like Kafka, for example, I believe there's like a 1 MB limit. And so when debugging this, I guess the question is two parts. One, how should we debug the event? Like, should it be that large, right? Maybe there's something that shouldn't be making it that large. And the second part of it is if it should be that large, how should we kind of maybe can OpenLineage handle? I know the HTTP transport has maybe a compression feature, but just curious how we can handle it from those two aspects.
So there is few kind of sources that can produce this kind of large message. One is n square amount of dependencies in column level lineage. And we had some issues where like you have 1,000 columns in an input, 1,000 columns in an output, and all of those columns were kind of considered to be dependencies of each other. So you can see that we already had 1 million connections. And this is a bug, right? If you see something like that, it most likely is a bug. And we should eliminate this. Another source is, yes, some facets, most should be turned off by default, can include some large information. Source code facet, yeah, I think if you have some very large source file, it can contain this. And yeah, the partition can sometimes the partitioning stuff right now. And I think you actually mentioned it, right? If somebody uses wildcard in input or something like that, and there's thousands of source of inputs, let's say files, it can be the source of that. But I think the partitioning should take care of this one use case. But yeah, I guess notifying us in Slack or GitHub and discussing the steps is the way. I think we should really try to make the events smaller than 1 MB. And there are some cases where this is a valid event, but it's problematic for consumers. Yeah.
Right. That makes sense. I am aware of because there was a new feature. I don't think it's by default yet. The dataset column lineage flag that will separate those two out, so it's not as large of an event. And then, like you mentioned, I think the logical plan, the debug facet, and I can ping in Slack. But curious if you said something about source code facet. There's another one you can disable or turn off.
Yes, great. Yes, I think source facet can be a source. But if you have some examples, yes, creating an issue and showing us the example, like
Okay.
it would be helpful.
Yeah, yeah, I can definitely post something on GitHub or Slack sometime soon. Thank you.
Okay, thanks. I think we're out of time. So see you.
See ya.
Thank you all.
Thanks,
Hi,
everyone.
everyone.